concept that can help you detect sets of words that make sense together. And it's the pointwise mutual information. Pointwise mutual information has been, there are a couple of studies there that have proven that the higher the pointwise mutual information number or score, the higher people think those words make sense together. So for example, if I said Manila marker, that makes no sense. Or Manila tape, that makes no sense. But if I say Manila envelope, you understand that I'm referring to those office envelopes that are yellowish in nature, right? Those are called Manila envelopes. If I say, for example, a collocation for bread and butter, right? Bread and butter seem to be one thing. However, if I say bread and hard drive or bread and phone, they don't make any sense together. They're not a thing, right? So there is a score, this pointwise mutual information, that is able to capture how much one word contributes to the other, meaning how much they make sense together as opposed to being very independent. And the score has to do with exactly those two parts. The probability that the words occur together as one thing in a collocation of whatever distance versus the probability that each one of them occurs independently from the other. Okay? So let's look at how this works. If two words occur independently from each other, right? If, let's say, two completely independent words, the probability of the first word times the probability of the second word, that is the probability of them being independent. Now, if they never occurred together, this number is going to go close to 0. Therefore, the PMI and this number, because of the probability of one word times the probability of the other, this will be some number, right? But this whole result will tend to go to 0 if the probability of W1 and W2 is very small, right? On the other hand, if two words occur together, they do not occur together independently, their probabilities are whatever you want, but the probability of finding them together is much larger now. It's much larger. It grows. It's not going to 0. It's actually increasing, right? The more the words make sense, this probability of finding them is larger and larger. So this coefficient will become larger and larger. So for example, if you have the word bread and butter, the probability of bread and the probability of butter together, right, independently, it's probably about the same as the probability of bread and butter occurring together, right? So wherever bread occurs, butter will likely occur, and you know what? They probably will occur together. So this probability here is very similar to this probability here, and then there will be some number here to compute the logarithm 2 of, right? Now, here's the other thing. If I think of bread and hard drive, the probability of bread will be something, the probability of hard drive will be something else. But probably bread and hard drive are very unlikely to be in the same document, so this will be close to 0. Okay? This will be close to 0. Now, if there's the same probability of them occurring independently than together, right? That means we have something. That means that we're approaching to a larger and larger number. Okay? Now, because the probability of one word times the probability of the other word, because these are small numbers, this number here is very small. Okay? So if they occur together, right? If they always occur together, let's assume that there's a set of words that is always together. The probability of it occurring together independently from this probability of occurring together is going to be a very small number. Where this number here, it's going to be much larger. Okay? Because this is basically whenever you find W1, you will find W2. That's very close to one of these two probabilities here, right? But when you multiply the 2 in the bottom, this number goes very, very small. And this number here, the total number here, grows very, very big, okay? So again, when two words go together, you're likely to find them together more times, and this whole number will be bigger. When two words don't go together, this number here becomes incredibly small, almost 0, and this whole number becomes close to 0. Now, how do you compute the PMI? Well, if you do the math on this, it's basically the following. You count the number of times the two words appear together, You count the number of times that each word appears independently. You multiply these two here. This other count goes here, and you multiply by the number of total words. And you get the logarithm in base 2 of that. That will give you the PMI, which is this ratio between the probability of the words happening independently versus the probability of the words happening in the same context, in the same little window, and therefore a collocation. That'll give you a pretty good insight on whether these two words make sense together.